Welcome. In this video we learn on Introduction to Hadoop. In this video we learn Introduction, Hadoop's history and advantages. Architecture in detail. Hadoop in industry. Hadoop is an Apache open-source framework written in Java that allows distributed processing of large datasets across clusters of computers using simple programming models. A Hadoop frameworked application works in an environment that provides distributed storage and computation across clusters of computers. Hadoop is designed to scale up from single server to thousands of machines, each offering local computation and storage. Hadoop is written in Java and currently used by Google, Facebook, LinkedIn, Yahoo, Twitter, etc. Our Hadoop tutorial includes all topics of Big Data Hadoop with HDFS, MapReduce, YARN, Hive, Base, Pig, Scoop. We can use following diagram to depict these four components available in Hadoop framework. Hadoop Common. These are Java libraries and utilities required by other Hadoop modules. These libraries provides file system and OS level abstractions and contains the necessary Java files and scripts required to start Hadoop. Hadoop YARN. This is a framework for job scheduling and cluster resource management. Hadoop Distributed File System, HDFS. A distributed file system that provides high-throughput access to application data. Hadoop MapReduce. This is YARN-based system for parallel processing of large datasets. We can use following diagram to depict these four components available in Hadoop framework. Since 2012, the term Hadoop often refers not just to the base modules mentioned above but also to the collection of additional software packages that can be installed on top of or alongside Hadoop, such as Apache Pig, Apache Hive, Apache Base, Apache Spark. Big data planning. Deployment is hard. What is equally hard and some might say even harder is doing big data QA/testing. There are many questions that need to be answered before taking the first steps in coming up with a test plan. Shortcomings in testing can result in poor data quality, poor performance and less than stellar user experience. Big Data Hadoop implementation deals with writing complex Pig, Hive programs and running these jobs using Hadoop MapReduce framework on huge volumes of data across different nodes. Here are 5 quick steps to get your testing efforts on the right path. 1. Document the high-level cloud test infrastructure design, disk space, RAM. 2. Required for each node. 3. Identify the cloud infrastructure service provider. 4. Document the SLAs, communication plan, maintenance plan, environment refresh plan. 5. Document the data security plan. 6. Document high-level test strategy, testing release cycles, testing types, volume of data processed by Hadoop, third-party tools. MapReduce. Hadoop MapReduce is a software framework for easily writing applications which process big amounts of data in parallel on large clusters, thousands of nodes, of commodity hardware in a reliable, fault-tolerant manner. The term MapReduce actually refers to the following 2 different tasks that Hadoop programs perform. The map task. This is the first task, which takes input data and converts it into a set of data, where individual elements are broken down into tuples, key-value pairs. The reduce task. This task takes the output from a map task as input and combines those data tuples into a smaller set of tuples. The reduce task is always performed after the map task. typically both the input and the output are stored in a file system. The framework takes care of scheduling tasks, monitoring them and re-executes the failed tasks. The MapReduce framework consists of a single master job tracker and one slave task tracker per cluster node. The master is responsible for resource management, tracking resource consumption, availability and scheduling the job's component tasks on the slaves, monitoring them and re-executing the failed tasks. The slave's task tracker execute the tasks as directed by the master and provide task status information to the master periodically. The job tracker is a single point of failure for the Hadoop MapReduce service, which means if job tracker goes down, all running jobs are halted. Hadoop Distributed File System. Hadoop can work directly with any mountable distributed file system such as LocalFS, HFTPFS, S3FS, and others, but the most common file system used by Hadoop is the Hadoop Distributed File System, HDFS. The Hadoop Distributed File System, HDFS, is based on the Google File System, GFS, and provides a distributed file system that is designed to run on large clusters, thousands of computers, of small computer machines in a reliable, fault-tolerant manner. HDFS uses a master-slave architecture where master consists of a single name node that manages the file system metadata and one or more slave data nodes that store the actual data. A file in an HDFS namespace is split into several blocks and those blocks are stored in a set of data nodes. The name node determines the mapping of blocks to the data nodes. The data node takes care of read and write operation with the file system. They also take care of block creation, deletion and replication based on instruction given by name node. HDFS provides a shell like any other file system and a list of commands are available to interact with the file system. These shell commands will be covered in a separate chapter along with appropriate examples. How does Hadoop work? Stage 1. A user application can submit a job to the a Hadoop job client, for required process by specifying the following items. The location of the input and output files in the distributed file system. The Java class is in the form of jar file containing the implementation of map and reduce functions. The job configuration by setting different parameters specific to the job. Stage 2. The Hadoop job client then submits the job, jar, executable etc., and configuration to the job tracker, which then assumes the responsibility of distributing the software, configuration to the slaves, scheduling tasks and monitoring them, providing status and diagnostic information to the job client. Stage 3. The task trackers on different nodes execute the task as per MapReduce implementation and output of the reduce function is stored into the output files on the file system. Advantages of Hadoop. Hadoop framework allows the user to quickly write and test distributed systems. It is efficient, and it automatically distributes the data and work across the machines and in turn, utilizes the underlying parallelism of the CPU cores. Hadoop does not rely on hardware to provide fault tolerance and high availability, FDHA, rather Hadoop library itself has been designed to detect and handle failures at the application layer. Servers can be added or removed from the cluster dynamically and Hadoop continues to operate without interruption. Another big advantage of Hadoop is that apart from being open source, it is compatible on all the platforms since it is Java-based. Thank you for watching this video.